Okay, it is time to finish the Monty Hall game show. Congratulations if you were able to do it. If you had a little trouble, you're in good company. I'm going to show you how I did it. There are a lot of ways you can do it. So, if you did it differently, see if you can kind of use what I did to do it a little differently. So, I'm going to do it here using this Play Monty definition. I'm going to go ahead and copy it though. So, the way you copy notebooks, you just click Save a Copy in Drive, and then you can see it brings up the new copy. So one thing we need here is another parameter, and it's switch. Like, are we going to switch doors? And so, for instance, that could be true or it could be false. So let's start it with false, and we can always change it to true later. Okay, so I like the doors equals 0, 1, 2, 3, right? And the prize door, great, that works. You could, when you're defining functions, by the way, you could put your random up here so it doesn't import it every time. Should make things a little faster. And now, okay, we've got to let's do this properly. We've got to give the switch option. Okay, and so what I'm going to try to do is find the door that the user can in fact switch to. So the way I can do that is I can first of all remove doors.remove the prize door, because the prize door is not going to be revealed. Okay. Next, we don't know if the user door and the prize door are the same. So frankly, if they're not the same, so if this is not equals, by the way, so if user door is not equal to the prize door, then what you can do, you can say, you can remove it. Because you can't remove something that's not there. Okay? So doors.remove user door. See if they're not equal. Now you've eliminated it. And so the next thing to do is to reveal the switch door. Okay? So there's an interesting way that you can do this. And simply put, we don't know in the code at this point whether there's one or two doors for Monty to choose from, right? Because if you've chosen a different door than the prize door, he doesn't have a choice. But if they're the same, he's supposed to make a random choice. But here's the cool thing. If you only have one door to pick from and you randomly choose, you're always going to get that one. So you can actually reveal the switch door using random again. Okay? Random.choice doors. Okay, so let me put in the code here so far that we have comment on it. So there are 3 doors to choose from. And so basically what this is doing is explaining the next line of code. Okay. The prize door is randomly chosen. The prize door is removed from, see, because you're going to reveal one of the doors. So suddenly the doors become our switch doors, really is what they are. And then this next line says, well, if user door is different than prize door, get rid of it. Really, I should call these the switch doors. And then now the switch door can be revealed. So it's either, so it's 2 cases here. There's one left, or randomly choose between 2. Okay, and now you give the person the option to switch. So this is where the switch piece comes into play. So and you could print it out, like, and it can be fun to actually do it one time, to actually print it out and put in like user input. That's actually great, but I want to get to the probabilities of it. So see before, so now it's going to be if switch. Okay, so now we need to figure out how to do it right if we're going to switch. Okay, because if you're going to switch, let's see. I feel like I did it in a roundabout way. Yeah, here's the deal. This switch door is not where the prize is, so you'd be switching to the other door. That's where I think it tripped me out the first time. It had to do maybe with how I labeled it, right? Because when Monty reveals, quote, the switch door, you could say it's the goat door. That might make it a little clearer because that's not the one that you're switching to. Okay, so what you're switching to is the other door. Okay? And this is the thing, we don't know whether that's the prize door or another goat. So how do we do it? What I did, which is probably not the most efficient method, I decided just to redo it and say, hey, I'm starting over. Doors equals 1, 2, 3. And if you're going to switch, clearly I'm removing the user door, right? Because you're switching. So you're not using that one, but you're also removing the goat door. By the way, the goat door, I think, it gives you also a little bit of hint on what the correct probability is, because note that you're removing clearly like one that's wrong. And then see, now the user door is going to change. So the user door is now the only one that's left. And again, you can get that from the 0th index. Okay, so what this chunk of code does basically says, if switch is equivalent to true, you're going to reset door options and then get rid of user door, get rid of revealed goat door, goot door, and change user door. And we still don't know if that's the victory or not. Okay, and finally now we just say, well, did you win? Well, clearly, if user door equals prize door, you win. Okay, and this is actually good here. I think we have it at the bottom. So check to see if prize door, check to see if user wins. Okay, and I believe these all need to be tabbed. No, they're okay. Okay, so I think that should do it. Let's try it. So again, note key it's to have 2 parameters. The user door, which again you could add a lot of fun elements to this game. You could make this random, okay, each time. You could also do printouts, like telling the user like to actually play it with people to make it a little fun. But I want to get to the probability. So first, let me run it. And then we can play it. So it's still called play Monty. And again, I can rewrite it. I'll just put in the parameters here. Switch by default is false, so you're going to keep, and we lose. And I can try true, and we win. So now this is where it becomes interesting. You can see what's going to happen if you switch all the time or you don't. First of all, let's never switch. You always keep the same door. And maybe let's keep it at 10,000 for now. Let's see. Okay, so if we never switch doors, this should be basically what we got before, about 33% of the time. And there you go. We win 33% of the time. Again, 33% of the time. What if we always switch? Okay. 67%. 66%. I'm not rounding, I'm just taking the first 2 digits, and so on. If you want to get it exact, just add another 0. So now we got 100,000 runs. Programming is fast these days. 66%, close to 67. 66. So you're winning 2/3 of the time if you don't switch. And I'm sorry, if you do switch, you're winning 2/3 of the time. And if you always hold on to that original thought, you're winning 1/3 of the time, which matches at the very beginning. You only have a 1/3 chance. there's a fun scene from the movie 21 where they go over this. And basically it says that when you reveal, oh look, there, in this case, the door, the new cars behind door number 2. When you reveal the goat behind door number 1, it changes everything.